Okay, so estimating a population mean when we don't know the population standard deviation, you're going to do pretty much the same thing we did in 8.1, except instead of using z, we're going to use a new distribution, t. Okay, so I'm going to show you guys that. So in the previous section, this is what we used, etc. However, this begs the question, how does one create a calculated confidence interval if the population standard deviation is not known? Okay, because we can't gather all of that data. This question was answered by William Gossett in 1908 using the pseudonym student. Gossett published the t distribution, so that's referred to as the student's t distribution, is a family of distributions that takes into account the sampling error of the standard deviation for small sample sizes. Why? For small sample sizes, the difference between the population and sample standard deviations is more pronounced, leading to greater variability. So if you look at the right with the tables here, the t distribution looks really similar to the normal distribution. Okay. The t distribution has a parameter, degrees of freedom. Degrees of freedom is just the sample size minus 1. So right here, degrees of freedom, sample size minus 1. Okay. If we look at this above, it's going to be different when the sample size is smaller. So the heavy dotted line, when the sample size is 2, the tails are just heavier than the z distribution. And then so if you look at the light dotted line, it starts to get closer to the z distribution or the normal distribution as the sample size gets larger. Okay, let me show you the t chart. So I did put this in the course notes for you guys. You can also do it on your calculator. So I'm going to show you both, and I'll have this printed out for you. But if you go to formula sheet, I put a link here to the t-table that I'm going to print out for you. Okay, so this is the t distribution. So we're going to look at the desired confidence levels and then the degrees of freedom. Okay, so let's say you had a sample size of 20. Your degrees of freedom would be 19. So depending on your confidence level, these are the values you use. Okay, notice this chart stops at 30, because remember, for the central limit theorem, 30 is a good sample size. Once you get over that, 40, 50, 60, 70, to infinity. Now the infinity ones, look at the 95%, 90%, 1.645. Then 99%, 95%. They're the same as the z values. So the larger the sample size gets there, the t and z will be the same. Okay, and I'll show you how to find it in your calculator in just a minute. Formula is the same for the confidence interval, x bar plus or minus e. However, for e, you're going to do t times the standard deviation of x bar. Okay, so to find the t value, we're going to calculate the degrees of freedom first, which is n minus 1. You're going to locate the row equal to that, and then the column, and that will be your t value. So let's do an example. The American Automobile Association, better known as AAA, publishes the average daily gas price for the entire nation as well as individual states. To estimate the average gas price in Florida, AAA contacted a random sample of 50 gas stations from around the state and found that the average gas price was $2.46 per gallon with a standard deviation of 15 cents. You can tell that this was written a couple years ago. So it's definitely not what it is right now. Okay, so let's go through this step by step. So first of all, the way that the information is given, that's how you have to ask yourself first. So how is the standard deviation given? The standard deviation is given from this sample of 50 gas stations. So this is a sample standard deviation, which means we're going to use the t distribution. Okay, so first thing you do, I know this is in the section for t, but once you get to the test, the sections aren't going to be separated like that. So first thing you do, ask yourself that question, how is the standard deviation given? Okay. All right, then let's see what we have. So the sample is 50 gas stations, so that's our sample size. Our average from that sample is 246. So that's our X bar. And our standard deviation of our sample size is 15 cents. Okay, the point estimate, that's X bar, 246. Margin of error for a 99% confidence interval, margin of error is T times the standard deviation of X bar. So let's first find that standard deviation. Okay, that's given by the standard deviation of the sample divided by the square root of the sample size. Okay, so chapter 7 formula is there. That standard deviation is 15 cents. The sample size is 50. So 0.15 divided by the square root of 50 is 0.0212. All right, the t value. So for the t value, okay, we would first need to find the degrees of freedom. So the degrees of freedom is our sample size minus 1. So our sample size is 50. 50 minus 1, 49. Okay, now if I am using the chart, I don't need to do anything further. I just go to the chart, and I say, well, I don't have 49 on here, so I'm going to use the row for 50. And I wanted 99%. So 99, see this says 99.8, 99. Ignore those. So 99% right here. 2.678. Okay, so using the chart is actually easier, I think, than doing this in the calculator. And let me show you why. Because remember, when we did the z in the calculator, we had to subtract from 1 and then divide by 2. You have to do the same thing here. Okay, so in our calculator, okay, here's what we're going to do. We're going to do 1 minus 0.99, which gives us 0.01. Then we're going to do 0.01 divided by 2, which was 0.005. Okay, then we're going to go to our calculator, and we're going to go same place where we would have gone for our z. So second distribution, instead of inverse norm, the one right below that, inverse t. So inverse t, area 0.005, degrees of freedom 49. There we go. So it'll give you the negative value again, just like before you had the in the z's. So negative 2.68 or 679, 2.68 if I rounded that. Okay, so second distribution inverse t. Okay, so that gives us 2.68. So whether you use 2.68, 2.678, it's so close, it's not going to matter. Okay, I'll show you the difference when we do the calculator, the whole thing here. All right, so we have our t, we have our standard deviation, so let's find our margin of error. So 2.678 times 0.0212. It's going to give us 0.0568. Yeah, 0.0568. Okay, so we have our margin of error, and then we'll do our confidence interval. So our confidence interval is x bar plus or minus e. So here our x bar is 246 plus or minus 0.0568. And when I do that, after I do that, I can round 2 decimal places because it's money. So for money, we really want to be 2 decimal places. So 246 minus 0.0568 would round to $2.40. Oh, that would be great right now, huh? 246 plus 0.0568, $2.52. So really, the whole steps are the same. You just have to do t instead of z. So if you use z, if it's a smaller sample size, it's going to be too far off. And then you could get the question wrong. So really, it's identifying, once you get the steps of how to do the confidence interval, it's identifying which value that you need to use. We can do this in our calculator. Okay, so we're going to go stat. It's on the next page. Same thing we did for the confidence interval for z. So stat tests. Okay, we're not going to do t or z interval, we're going to do t interval. So number 8. Okay, then we'll put this in. So our x bar was 246. Our standard deviation, the original one, 0.15. Our sample size was 50. And we did a 99% confidence level. Okay, now this takes a minute because it's got to look up the values. But there you go. $2.40, $2.52. All right, let's do another example. Okay, so the U.S. Bureau of Labor Statistics releases a monthly report on the average hourly wage of American employees. A recent sample of 500 American employees produced a mean hourly wage of $28.18 with a standard deviation of $1.35. How is the standard deviation given? Sample. Okay, so this is T. All right, let's write down what we have. Sample size, 500. That's a large sample size. So this one, actually, we would use the infinity value on the Z chart or T chart. Those would be the same as Z. So this one, you could have gotten that first question wrong and been okay. But if it were a smaller sample size like 50, then that's where it really matters. Okay, and then our X bar is our point estimate, 2818. And then our standard deviation of our sample is 135. All right, margin of error, T times standard deviation of X bar. Let's go ahead and find that. So that's going to be our 135 divided by the square root of 500. So 0.0604. Okay, then our T value for 98%. Okay, our degrees of freedom is going to be our sample size minus 1, so 500 minus 1, 499. I go over to my chart. 98% is this column here. So that's going to be this 2.327 for my T value. Okay, or if I want to do that in my calculator, I would do inverse t. Then my area would be 0.02 divided by 2, so 0.01. And then degrees of freedom, 499. Okay, so again, 1 minus 0.98 would give us that 0.02. We would then need to divide that by 2 and put 0.01 because we want to look on both tails. Okay, we want 0.01 over here, 0.01 over here. So let's see if it gives us the same thing. So second distribution, inverse t, area 0.01, 499. .333. A little bit further off, but close enough. Now, which one do we want to use? It doesn't really matter. It's multiple choice test. The answers are not going to be that close together. Okay, we can look at it with both if we want. So let's say we use the 2.327. So t times the standard deviation of x bar would be 2.327 times 0.0604. That gives us a margin of error of 14 cents. And let's just say we use the 2.33, 2.334 times 0.0604. It's still 14 cents, so it's not going to matter. Okay. 1405 versus 141. So our margin of error there, okay, it's money, so we really only want 2 decimal places for the answer. So that it doesn't really make much of a difference. The confidence interval gives us 2818 plus or minus this 14 cents. So that would be 2804. And then 2832. Okay, checking that in my calculator. I want my t interval. Nope. Not the 2 sample one. All right, so that is 2818. Standard deviation 135. Sample size 500. And we do 98% there. $28.04, $28.32. Okay. We still have a couple more, but we are running out of time. But what I want to do for this one is I want to go over it. I'm going to do it in the calculator, though, because I want to get it on the recording. A lot of you guys forgot how to do this when it gives you the raw data. This is back to chapter 1. Okay? So, just you can follow me in your calculator if you want or not. I am recording it, so I'll put this up on the video. The college would like to estimate the average number of hours students work per week. Suppose 15 students are randomly selected and asked how many hours they work per week. Here's the results. So what we want to do here is we are going to take these results and then we're going to do the confidence interval around them. In order to do that, we need that point estimate. So we need the average. We need the standard deviation. Okay, so remember how to do that. You probably don't remember how to do the calculation by hand. We do have the formula though. But we can put this in here if we remember. We put it in a list. Okay, so here I would go to stat, edit, put this in L1. And I actually already have it put in here, so, because I did it this morning. But 10, 8, 0, 12. So you're going to put this whole list in the list for your calculator. Then you're going to go back to your home screen. And then remember where that is? Stat, calc, one variable statistics. We just want those for L1. Okay, so that gives us an X bar of 16.8. It's a sample, so that standard deviation is going to be the 11.706. Okay, so X bar 16.8. Standard deviation of the sample 11.706. Sample size was 15. Okay, so just to remember how to do that. And then I'm just going to go ahead and we're going to do this confidence interval in the calculator. So we're going to go to stat, tests. We want the T interval. And look, it has it in there because we had put the data in before. So it sometimes automatically computes that. We just have to change the confidence level, 0.90. Okay, so there you get the confidence interval 1148 and 2212. Okay, now let's say you still need to answer the question about the margin of error. What we would do there, if you wanted to find the margin of error, just work backwards. Okay? You know that the confidence interval is X bar, put that here, CI equals X bar plus or minus the margin of error. Well, we know what the confidence interval is, and we know what X bar is. So we could just use one of these. So 11, or we'll use the higher one. So 2212 is that value. X bar is 16.8. And we had added E for that one. So if we subtract 16.8, that will give us that confidence interval. Or, sorry, that margin of error would be $5.32. Would have been that E. Okay, because we would have done 16.8 plus 532. That gives us that 2212. And then 16.8 minus 532. 1148. Okay, the only other answer or question you might have to answer is like, what is the t-value associated with this? In which case you can go to the chart. Degrees of freedom there would be 14. So 14 and 90% right there. So it would have been a 1.761 for the confidence, or for the t-value. Okay, now there is a little bit more here. Actually, that was, oh good, that was it for the class. So you guys have this, but we don't have time for the classwork, but I'm going to show on the video where you can get it for anyone watching. So, going back to the course homepage, you guys can just go to notes and lectures and filled in notes. Chapter 8 filled in notes. And you should have the answers to those practice problems. There it is, with my work as well. Okay, but if you have any questions, please let me know. Okay, if you want me to make a video for those or anything like that.